Hello and welcome back to this course on fundamentals of data science. We are still dealing with some of the basic informations of foundations of data science. And here we are in week 2, session 2. Today we are going to discuss in detail about some of the data pre-processing methods, including data cleaning, data integration, and data transformation, and finally about data reduction. So that's the contents that we are going to look at in today's lecture. And our objective for today is, why do we need data pre-processing? And when it comes to data integration and transformation, why it is essential? Finally, about data reductions. Well, some of them is quite obvious for you. When it talks about data integration, you are integrating various data, and transformation, again, you already familiar with why do we have to transform the data from one format to another format, or from an unstructured data into a structured data. Let's look at few more aspects of these topics. Well, when it comes to why do we need pre-process, in the real world, almost all the raw data that we have in hand are kind of dirty. In other words, they are incomplete data. It lacks attribute values, lacking certain attributes of interest, or contains only aggregated data. So these data are sometimes not useful for us. Some data are inconsistent. As you can see here, it contains the discrepancies in codes and names. For example, it says age is 42, but the birthday is like 1997, which is not correct, we know, right? And maybe previously you had the ratings like 1, 2, 3, and now you have the ratings like A, B, C. There is this problem of data inconsistent. And there are some more issues like noise data. At times it contains errors or outliers which are quite hard for us to understand. For example, like salary is in like -10, which we know that it is of course an error, and family like unknown. We are not having the information of a person or his family. So likewise, in real world, we have this inconsistent data, or at times incomplete data. That's why we want to make sure that we do certain pre-process, and then you collect the informations or data before processing it. No quality data, no quality mining results. Does it sound familiar? Yes, it's like garbage in, garbage out. If you don't have a good data for us to input, then you don't have a good analytics. You cannot analyze a better one. That's the key part, right? If you don't have a quality data, your whole process is not going to have the quality. The quality decision must be based on the quality data. Duplicate or missing data may cause incorrect or inconsistent or even misleading statistics. So data warehouse needs consistent integration of quality data. That's the first point. The second one is data extraction, cleaning, and transformation comprises most of the work of building a data warehouse. Yes, as we have already seen, almost 70% of your work has to do with data pre-processing and data processing, even before analyzing. It is a very laborious task. It takes more time. There are tools available to help us these days, but still unless you are good in your domain, you are not sure what you are looking at. As we have seen, you have to come up with the right questions and then with the right data. If you have the questions right, but if your data are not right, still you are not going to achieve your goal. So what are the major tasks of data pre-processing? Basically, the 4 main tasks are data cleaning, data integration, data transformation, and data reduction. So when it comes to data cleaning, at times we have noisy data which you have to filter out, or you may have to remove outliers. At times you have missing values, you may have to fill in the missing values. So that's the first part of resolving the inconsistency in the data, the cleaning part of the data. Then you have to integrate. The integration of multiple database, we call data cubes, files, or nodes. So when we talk about, say, air pollution data, at times we do have air pollution data, for example, the particulate matter, CO2. Then you have other data like maybe weather data you have to integrate, like how warm, how humid it is it rainy. Then you may have to integrate, say, water pollution data or the sound pollution or noise pollution, just to make sure it's quite complete. You are integrating all this information to support your community, and you give the information to the community after analyzing it. Then comes the data transformation, where you can normalize or scaling to a specific range. You can normalize your data, you can aggregate your data, accreditation can be done there. So sometimes we have data in one format and we may have to transform into another format. There are some data which are in frequency domain and it has to be converted into time domain. There are data which are of sound signal, analog signal, and they have to be transformed into a digital signal. There are some data which are of video signal. Again, this has to be digitized so that it can be processed and analyzed later on. So likewise, there are a lot of data transformation methods are available. So we want to make sure our data are transformed in this data pre-processing step so that later on it can be used for data analysis. And finally, we have this data reduction. When it comes to data reduction, we want to make sure that we don't want to use the whole volume of data that is being produced by all these devices. We want to use make sure we want to use the needed data. So at times we can discretize the data. In other words, you can use the important data that are needed. Like you can filter out some informations that are not essential. You can use a compressing method to compress it, and we can also reduce the dimensionality. For example, at times you may have 3-dimensional data. You can reduce to 2-dimension, by which you can reduce a lot of computation. Data cleaning, we have already seen few methods of that. So basically, why data cleaning? Data cleaning is one of the 3 biggest problems in data warehouse, as said by Ralph. And data cleaning is the #1 problem in data warehouse. So DCI survey says that. Yes, data cleaning task includes fill in missing values, identify the outliers, and smooth out the noisy data. If there is any inconsistent data, try to correct the inconsistency, resolve redundancy caused by data integration. Coming to missing data, you can look at here this graph, for example. From this point onwards until this point, there is no data available. So it's been just connected with a straight line. Well, at times it happens. We do have missing information in almost all the data that we collect due to various reasons. We are not sure, maybe it is due to the sensor malfunction, or it may be due to inconsistent with other recorded data. So maybe some data got deleted and data not entered due to misunderstanding or just left blank. As certain data may not be considered important at all, so just they leave it as blank. Maybe because of that we have the missing data. Some registered history or missing. Sometimes we intentionally maybe change the data and eventually it got lost. Sometimes it's human error. We just, because of human error, we misplace information. So missing data may need to be inferred correctly. We can use various simple methods to impute that missing data. Then comes the noisy data. As far as missing data and noisy data is concerned, they are kind of different. Missing data is actually there are values that are supposed to be there and it is missing. One of the example I would like to give is, as we can see here, from 10:22 till 10:45 data are missing. So what kind of data are we going to fill in here? This is a little bit tricky. We are not sure how this to be filled. But for example, you have some data, say like 27, 28, 29, then you have missing data like say, then you have 30, 31. If this is the case, at times you can able to predict what would be the next value more easily. Some people prefer to leave it as blank. They don't want to interfere with what is being left over, but others try to take an average of these two values and then fill in here. Maybe this is 29.5. Or sometimes you can also predict. There are different algorithms these days available to find the missing data. Likewise, when it comes to noisy data, there again, because of various fault while collecting the data by the instrument, there may be some noise. And this noise are also recorded in your data. So data has been entered into your database and they have some noise in it. So inconsistency in various ways. So here is an example of how inconsistent data can be. Here H Shri, the naming convention, for example, a name H dot Shri or H Shri or H dot Shri. In this case, you do have a blank space here. Then H Shri. There is no full stop or there is no dot and no. We do have a blank space there. So a different way of expressing a name convention. This can also be a simple problem, but sometimes it's annoying. There are other data problems which requires data cleaning. That includes duplicate records. Yeah, suppose you are collecting data and for example you are collecting data every day. You are collecting some information, say for example today is 2021 or say, and then you have another data. So you have data for every day and suddenly there is something missing or sometimes it's repeated, say for example. So when you see a data that is repeated, you can easily identify this data is repeated, and you can delete one of that data right away. You can omit the duplicates. That's one of the suggestions that we have. And when you have incomplete data, we can also go for interpolation method, just like this, interpolate and then find or estimate the data. When you have inconsistent data, decide which one is correct. There are a few methods that are available to understand the domain and then decide which one is the correct one that you want to use. Handling the noisy data. There are different ways to handle it. For example, one way is binning. First, you may have to sort out the data and partition into equal depth bins. You are just partitioning into bins. Then you can smooth by bin means, and smooth by bin median, and smooth by bin boundaries. So its mean is just the mean value, the average value, the median value, a simple statistics. Later on, we will learn more about how probability and statistics can be used for solving many of our problems in data science. And eventually it can help us even in machine learning. We are going to see how statistics are going to be used. So basically here, if you want to smooth out, we just take mean is one way. As we have seen also here in missing data, in this case we have taken the mean of the two values, right? The average of this value, or you can also take the average of the entire data and then you can fill in the missing information. Likewise, for noisy data also, you can do a similar thing to smoothen. You want to smooth out the noise data, you can use a mean as a good way to smooth out. You can also use regression method, smooth by fitting the data into regression function. And you know what is a regression? When you have a group of data points, you are trying to find the line that fits all the data points, the regression function, fitting the data into the regression function by which you can smoothen. You can also use clustering, by which you can detect and remove the outliers. Once you cluster out the similar data, the other data will be present outside, which means that that is a noisy data. So you can see here an example. It's just like a classifier. So this line has been drawn between these two groups, basically the blue and the pink, and you can see this region where the blue is, it's safely located. All these blues are safely located on in this side, but there are some blue ones that are in the borderline. This is in the borderline. This is in the borderline. Even these data, right? These are in borderline. But we can find these data are outside. In other words, kind of a noisy data that are present here, here, or the noisy ones. So, of course, which means that as simple algorithms can be arranged for such manipulation. In other words, still this research is kind of open, and people are working out to understand the noisy data and try to identify these data and try to see, can we really skip this data, can we remove it, can we have ways in which you can smooth out the data. Yes, combined with computer and human inceptions or inspections, you can actually detect some of the suspicious values and check whether these values are really the real data or a possible outlier. These are simple methods to handle noisy data. Data cleaning as a process. we can think about data discrepancy detection. So for example, you can check the field overloading, check uniqueness rules, consecutive rules, and null rules for data discrepancy, and data scrubbing and data auditing. Data scrubbing is just like sometimes you already know some given informations. For example, you already know the postal code, so you can use a postal code to detect the error and make corrections when needed. Likewise, for data auditing, by analyzing data to discover rules and relationship to detect any violators, we can use correlation and clustering to find some outliers in the data and check if there is any violation. Data migration and data integrations. So data migration tools allow transformation to be very specific, and the ETL, the extraction, transformation, and loading tools allows the user to specify the transformation through a graphical user interface. So you can have a look at these tools like ETL tools. We are not going to consider this in our course, so you can have a look at this ETL tools. Basically, there are simple mechanisms that are available, which is in fact helps us in data migration. And integration, when it comes to integration of data, there are various ways. You can use interactive ways or iterative ways for integrating the data. As we can see, data integration is nothing but the combination of data from multiple sources. Maybe for example, you have a customer ID, you have customer name, you have customer phone number. Yes, these can be integrated together. Likewise, entity identification. Identify and use real world entities from multiple data sources. That can be very useful. And finally, you have detecting and resolving data value conflict. For example, for the same real world entity, attribute values from different sources are different. So that is another possible ways. For example, like you may have a different scale, a metric scale versus the British unit. That can be at times confusing. So we want to make sure that we integrate it accordingly. We can use only one convention, not different conventions mixed up together. So likewise, the data handling redundancy in data integration is another part, because redundant data occurs often when integration of multiple database happens. So for example, we talked about integrating customer ID, customer name, customer say phone numbers, or all information together from one database, and then you are having the same customer information coming in from other database. So when you have multiple database, if you want to integrate it together, yes, that's where sometimes you repeat the same data, redundant data happens. Yes, these days even people have different email address, but the same person, right? Same person have a different email address, and he gives us different email address to the same, for example, same concern, and this has to be integrated together so that there is no redundant information over there. And redundant attributes may also be detected by correlation analysis. Later on in one of our lecture, we are going to discuss about correlation. At that time, you will come across this information. Data transformation. As far as data transformation is concerned, we are actually transforming data from one structure to another structure. In other words, at times the data are itself not structured data. We can convert or transform into a structured one. Sometimes the data itself in a very different form. It may be in a sound signal form, and you want to discretize, or you want to make it as digital signal. Yes, during that time you can also use data transformation. So smoothing, accreditation, generalization are some of the methods, and normalization is a very useful and very key factor in data analytics. So there are different normalization methods. Even for normalizing a covariance, we are going to use correlation. It's a simple normalization methods. So we can think about what normalization methods we can use to transform the data. Data reduction. Yes, it's very obvious that we really want to reduce the data. We don't want to use terabyte of data and to analyze or to compute. The computation complexity is quite huge when you have very huge database. So it is also always recommended to remove unimportant features or unimportant attributes from the data so that the dimensionality reduction can happen. You can actually compress the data and you can eventually reduce the data that is in hand. So there is one method like data cube accreditation is one of the features which has multiple levels of accreditation in data cubes, and these data cube accreditation can reduce the data to a drastic level, and eventually, as you can see, the dimensions and the reductions of the entire data has been compressed, and this is capable of solving a huge task into a smaller task. And this is where the data accreditation is a very useful tool. Also, in line with the data accreditation, data compression is also very useful for reducing the data. Typically, we use compression tools for compressing the lossy compression in audio and video and image compression. Basically, we also have something related to encoding and decoding, right? So when you encode the information, you are actually compressing the information and encoding it. And data compression is another huge topic that is people are working on in a lot of research related to audio, video, image, and data compression. So these are other methods in which you can reduce the volume of data or compress the volume of data before analysis. So that's what we see in this course. Basically, we talked about the reasons behind a data pre-processing. Now you are familiar with why do we need a data pre-processing as such. Yes, a lot of things are done even before processing and analyzing the data. And these are some of the key parts in which you are cleaning the data, you are integrating the data, you are transforming the data, you are reducing the data. In fact, if the data are missing, you are trying to replace the data. Yes, data in real world are dirty. It's always that way. We have to clean it to make sure that we can extract the useful information from the given data that is in hand. That's what we have for today's lecture, and in our next lecture, we are going to talk about different types of samplings and basis for probability, types of probability and probability line. Basically, we are going to see some introduction to sampling and introduction to probability. That would be the focus of our next lecture. I would like to see you there in the next lecture. Until then, goodbye.